right, so continuing on to lesson 11.4, normal distributions. So today we're going to dive into the normal distribution. Last section we explored three ways, three types of distributing data. We said that data can be either skewed left, normal, or skewed right. So today we're specifically looking at the normal distribution. And the normal distribution makes use of a really neat rule called the empirical rule. And what this empirical rule does is it says that you have your mean of data, and then that data is going to fall within 67% of that data will fall within one standard deviation of the mean. And then 95% will fall within two standard deviations of the mean. And then 99.7% of the data is going to fall within three standard deviations of the mean. So if you notice, I used a different symbol for mean up here. In the last section, we used the X bar. So what makes the X bar different from this symbol is called mu, is that the X bar is the mean of the sample, whereas the mu symbol is used for the mean of the population. So we're looking at the mean of an entire population here. So what the empirical rule is going to allow us to do is to make predictions about the population using this data here. And this rule is only good for normal distributions. So distributions that are either skewed left or right cannot use the empirical rule. So again, that empirical rule, you remember these numbers: 68, 95, and then 99.7. And we'll practice more with that later in the lesson. All right, go ahead and turn the page to page 25 now. That brings us to our first learning target. I can sketch and label a normal curve for a data distribution. So that normal distribution makes use of that bell-shaped curve. We learned that in the last section. So let's look at an example here. It says, an example of an early application was in the year 1817. A study of chest circumference among a group of Scottish men exhibited an approximate normal distribution. So it's that bell-shaped curve there. Their chest circumferences ranged from 33 to 48 inches with a mean, there's your mu, a mean chest measurement of 40 and a standard deviation of 2 inches. And remember from last section, standard deviation uses that symbol sigma. It's like an O with a little hat on it. So we're going to use the empirical rule to understand the distribution of this study of these chest circumferences. So the first thing we want to do is we want to draw our curve here. And to do that, we're going to first start with a horizontal x-axis. So let's do that. Just a straight line. This is going to serve as our x-axis there. Now we're going to draw the bell-shaped curve. So use your artistic abilities here to draw the best you can that bell-shaped curve. Try to make it as symmetrical as you can. Mine's not so great, but you get the idea. Okay, now we're going to label this. So we're going to label this curve. So we're going to start by putting mu in the center. We're going to put the mean of the population right smack in the center. All right, just like that. Now we're going to add 3 standard deviations to the right So 1, 2, 3. And then subtract 3 to the left. 1, 2, 3. So that takes care of steps 1 and 2. Here's the rest of, oh, you couldn't see that, sorry. Here's the rest of step 2 here. So we started with the mean in the center, add 3 standard deviations to the right, and subtract 3 standard deviations to the left. All right, now we're going to add labels to our x-axis. And it says to put the mean at the center. So here's our mean, and our problem says that the mean is 40 inches. So 40 is the label there on the x-axis. Now we need to figure out the rest of the values down there. So we're gonna do that by using our standard deviation. We're gonna count by standard deviation to each end of the curve. So we're here at 4. To get this line, we need to add 1 standard deviation. Now, our problem says our standard deviation is 2. So I need to add 2. So 40 plus 2 is 42. And then add another one. So this would be 44, and this would be 46. All right, we're going to repeat the same process, but this time we're going to subtract to go to the left. So this would be 38, 36, and 34. Now our last step is we're going to add those percentages for our empirical rule. This will come in handy when we're analyzing this data. So from 38 to 40, so 1 standard deviation of the mean, that's your 68%. And then 2 standard deviations gives you your 95%. And then finally 3 standard deviations gives you your 99.7%. All right, so now we're all set up. So let's use our graph to answer question B. It says, what would you expect the chest measurements to be for the 2.5% of the men with the smallest chest measurements for the population? So 2.5% would fall right within here. So 2.5% would be men with chests less than 36 inches. Okay. So what about this question? This is the one I want you to try on your own. What about the largest 2.5%? What chest size would the largest 2.5% be? Try that one. Okay, so the largest 2.5% falls over here. So this is going to be men with chests greater than 44 inches. All right. So the main idea here that I wanted you to take away from this example was basically just how do you sketch this graph? How do you make that normal curve and how do you label it? So make sure you know how to do this success criteria here. Okay, let's practice some more with this. So we're still going to use this concept, but we're just going to build onto it a little bit. So go ahead and go to page 26 now. And here's your second learning target. So I can use the empirical rule to find proportions. So now we're going to start making predictions with our data using the empirical rule. So here's our problem. Example 2. Recent SAT scores for college-bound seniors are normally distributed with a mean score of 508 and a standard deviation of 121. So there's your key information. You need the mean and the standard deviation in order to make that curve there. How does the empirical rule help you understand the performances of individual students? Okay, so let's look at the first part of the question here. It says, what proportion of students receive scores between 387 and 629? All right, so the first thing I want to do, here's my success criteria down here. The first thing I want to do is to draw my graph, and that's what we did on the last page, our last learning target. So we're going to use that success criteria to draw the graph. So let's work on that right now. So draw your x-axis, sketch that normal curve as symmetrical as you can. Okay, put your mean in the center, and then we're going to go 3 standard deviations each direction, adding to the right and then subtracting to the left. Then we need to label our x-axis. So we're going to start with our mean that goes right in the center. Mean is 508. 508 is the mean. And then our standard deviation here is 121. So we're going to add 121 to get each of these here. So 508 plus 121 is 629. And then add it again, 750, and then 871. Now do 508 minus 121 to get your next score here. 381, 266, and then 145. Okay, empirical rule says that one standard deviation is 68%. 2 standard deviations is 95. And then last one is the 99.7. All right, so that's your first step. Get your graph set up, organize your data, and you're ready to go. So step 2, now we're going to highlight the part of the curve we're looking for. So the question was, what proportion of students receive scores between 387, oh, this should have been 387 here, sorry about that, couldn't read my own writing, 387 and 629. So we're looking right in here. Well, that's an easy one because that's just one standard deviation from the mean, and we can use our empirical rule to answer that. Well, that's the 68%. So 68% of these students scored within this range, 387 to 629. Okay, now let's look at this one. Sketch the graph to see where the numbers 387 and 629. Oh, we already did that. Whoops, sorry, got it. Slow down here. All right, down here, this is what I was looking for. What proportion of students receive scores greater than 387? So here's 387, and the scores are greater to the right. So from 387 on, what is that percentage of students? Okay, so greater than 387 is in the pink there. All right, So that was my step 2. Highlight the part of the curve we're looking for. So I'm looking for the part in pink here. Now, we're going to need to stop here for a minute because we need to talk about some of these percentages here for your normal curve. So we're going to use our empirical rule to break this down. So this is 68%. So if I want just this piece here and this piece here, I can do 68 divided by 2. So that would be 34 and 34. 34 plus 34 is 68, okay? Now, to find this piece and this piece, I can say 95, and then subtract that 68, because that's taken care of right here, and then divide that by 2, because for this piece and this piece here. So each of these is worth 13.5. Okay, and I can repeat that process again. Now I want to find this piece and this piece. So I know this is 99.7. Then I'll subtract what I have here, 95. Divide that by 2. And it's 2.35 here and 2.35 here. And then the whole curve is worth 100%. So if I do 100 minus the 99.7, divide that by 2, I find that this piece is worth 0.15 and this piece is 0.15. And then this gives you your 2.5 here that we used on the other page. All right, so that's the breakdown. So we're going to use these percentages to help us out here. And also remember that half of this curve from here to here would be 50%, and also from here to here would be 50%, because 100 divided by 2 is 50. So use that piece of information plus these percentages, and then we can calculate what we need. So if we look back to our problem, we're looking for the students that receive scores greater than 387. So what's in pink there? So I can say, well, here's half. I know that this half is going to be 50%. So from here on, that is 50%. Okay? And then I know this piece here is 34%. So then I can say 34 plus 50 equals 84%. So 84% of the students scored greater than 387. All right, so I used my 50% rule, and I used my empirical rule to show me that this piece that I had left over was 34, so 50 plus 34 to find the total, and that is your answer for your proportion. Okay, so that's the lesson. You're going to have some opportunity to practice this on your own with your OTI, and that is it.